Now let's go for question C. The derivative is you have to use the product rule. When you differentiate the second one, you have to use the chain rule. So after differentiating this, you have to pull the inside function out and you differentiate, which gives you negative. So you end up with e to the negative x minus x times e to the negative x, which has a common factor e to the negative x. So if I factor out the e to the negative x, you end up with 1 minus x e to the negative x. Okay, now exponential functions can never be 0. So if you want to solve f prime equal to 0, which says e to the negative x 1 minus x has to equal to 0, and then when you have e to the negative x equal to 0, that never happens. No solution. Okay, and when you set 1 minus x equal to 0, you end up with x equal to 1, and x equal to 1 is therefore the only critical number. Choose a test point before and after. So before I choose 0 and after I choose 2. F prime of 0, well, if I plug it in here, you got e to the 0th power 1 minus 0. Anything to the 0th power is 1. 1 minus 0 is 1, so you end up with 1. 1 times 1 is 1, which means it's positive. F prime of 2, e to the negative 2, and then 1 minus 2. Well, negative power means 1 over, so you have 1 over e squared times negative 1. And since e squared is positive, 1 over e squared is positive. And if you multiply, you get negative 1 over e squared, which is a negative number, so it's negative here. That is the sign of f prime, which means f is going to increase and then decrease afterwards. Okay. Now, you see that this point, according to the first derivative test, I see that it's a relative maximum. It goes up and then comes down. Therefore, 1 comma, let's see, if I plug in 1 back into this function, I get 1 times e to the negative 1. So 1 comma e to the negative 1. This is your relative maximum. And then it's increasing on the interval negative infinity to 1. It's going up, and then decreasing on 1 to infinity. Okay, so that concludes question 4. Question 5. Now we're trying to do implicit differentiation. Important thing about implicit differentiation is that there is a asymmetry between how you treat x and how you treat y. X and y are different, although if you see it, it doesn't seem that x is any different than y, but secretly what's happening is that y is actually a function of x, and that's why x and y are different. This means that whenever you differentiate y, it's just y prime. Okay? Whereas if you differentiate x, it's just 1, right? And whenever you have y to some power, if you differentiate something like this, you end up with a nested function, because y is a function of x, which is nested inside the cubic function. So when you differentiate this, you're going to need chain rule. So just remember these things and you're going to be okay. Right? So first, step 1, let's try to differentiate. We're going to differentiate both sides. Differentiate left, differentiate right. X squared differentiates to 2x. 5xy, because this is a product of two functions, you have to make it, well, you have to use the product rule. And then as I said, this requires chain rule, so you differentiate as a function of y. So 3 comes down, you subtract 1 off of 3, so it's 3y squared. But then y is an inside function which you have to pull out and differentiate. And that is the big difference between treating x and y. Whenever you have a function of y, you better be using the chain rule. Okay, 8 is a constant multiple, so we just pull it out and we just have to differentiate ln x. Derivative of ln x is 1 over x. Okay, now let's continue. We have 2x. Derivative of 5x is just 5. And you have 5y, and then 5x, y prime is y prime. Plus 3y squared y prime equals to 8 over x. So that's the first step. You've done the derivative. Now the next thing that you have to do is we need to know what y prime is equal to. So you need to solve for y prime. The way you solve for y prime is you look at each term and identify the ones that have y prime in there. So here's one term which has y prime in there, right? And there's another one which has y prime in there. So these two should belong together, whereas the other ones should be on the other side. Okay, so we're going to leave the 5x y prime and 3y squared y prime on this side, whereas I'm going to subtract 2x both sides so that 2x becomes negative 2x on the other side. And then 5y becomes negative 5y on the other side. The reason you do this is because whenever you do it, then you can always factor the y prime out. And indeed, that's how you solve for y prime. Factor the y prime. Right side is same as before. And now you divide this entire thing, both sides. So if I divide by 5x plus 3y squared and 5x plus 3y squared, then these will cancel and you're left with the answer, which is y prime is equal to 8 over x minus 2x minus 5y over 5x plus 3y squared. Okay, now let's try to do question B. Question B is you differentiate both sides. They're both products, so you have to use product for differentiating both of them. Okay, so here, this is the derivative of this second part, where I use the product rule. And then the right side, y is a function of x nested inside the exponential function, so it's 3e to the y times y prime. X squared prime is 2x. 2x prime is 2. Okay, again, we identify the ones where you have y prime. So y prime, I see one here. I see another y prime in here. I see another y prime in here. So they all need to be on one side, whereas these two, the other ones that this one here and this one, these don't have y prime, so they belong together. Okay. So let's do this. I'm going to move the y primes on the other side and leave 2xy and y squared here. So we have 2xy plus 2y squared on the left side, whereas on the other side, these are moved away. So you have 3e to the y prime minus x squared y prime. When you move the terms, their signs become the opposite, right? Plus becomes minus. And then over here, this one, well, this is 4xy, right? So it's 4xy y prime. Now we can factor the y prime, and you have 3e to the y minus x squared minus 4xy equals to 2xy plus 2y squared. And then you divide this to the other side, and we have y prime equal to 2xy plus 2y squared on the top, whereas on the bottom we have 3e to the y minus x squared minus 4xy on the bottom. If you do a few more, you're going to see a pattern. You always have to differentiate using either the product rule or chain rule, and then after differentiating you have to solve for y prime by isolating the y prime on one side. Question C, it's getting more complicated. You have x e to 2xy equal to 4x squared plus y plus 17. We differentiate both sides. Now this left one is very complicated, but you are going to worry about the complicated parts later. Right now we just say, well, these two are products, so I'm just going to use the product rule. So differentiate the first, leave the first, now differentiate the second one. And key to solving these complex questions is not to do everything at once. Just do it in piecemeal, and at some point you're going to get there to the final answer. So 2 comes down, so you have 4 times 2, 8x. Y prime is y prime. 17 prime, because 17 is a constant, it's just 0. Okay, we still have to settle this part. X prime is 1, so you just have 1 times e to the 2xy. This part, we need the chain rule because 2xy is nested inside the exponential function. Exponential function's derivative is same as itself, so it doesn't change, but the inside function has to be pulled out and you have to differentiate it. Okay. Notice that I still didn't compute this yet because I want to I want to do this in the next step. Okay. Don't try to do everything at once. Just be patient, apply the rules that you know. At some point you're going to get to the answer. So I'm using the product rule because the product between 2x and y, so 2x prime y plus 2x y prime equal to 8x plus y prime. So you have e to the 2xy and then x e to the 2xy. You have 2x prime, which is 2y plus 2x y prime. Another thing that you may notice is that I'm just writing everything again. Seems like waste of time, but it's not. By writing things again and again, you make sure that you didn't forget anything. So it's a good habit. Alright, I see that this one has y prime, but this one doesn't. And that's going to cause some problems when you try to solve for y prime. So what I'm going to do is I'm going to multiply these out to break it into 2 terms. So e to 2xy, x times 2 times y, that's 2xy, e to 2xy, and then 2xy prime, x times x is x squared, so it's 2x squared y prime e to 2xy, and on the right side you have 8x plus y prime. Okay, so I guess this one has y prime, which should be moved, and this one doesn't have y prime, which should be moved. So that now I have on the left side all the terms that don't include y prime. Whereas on the right side, I have all the terms that include y prime. As usual, we factor the y prime on the right side. So I'm going to factor the y prime, which gives you 1 minus 2x squared e to the 2xy. Okay. The reason we have 1 is because you should think of y prime as 1 times y prime. So if you take the y prime away, it's 1. And you can check that these are indeed same by just multiplying them out. Okay, now we are trying to solve for y prime, so this will be divided to the other side, which gives you the answer. Y prime is equal to e to the 2xy plus 2xy e to the 2xy minus 8x over 1 minus 2x squared e to the 2xy. Okay, last one. D, square root of x squared plus 16y squared equals to 3. Now, sometimes it's easier if you first square both sides and then you differentiate. See, the square roots are really not so easy to differentiate. When you have a square root, you have to use the chain rule, and it's just complicated. So if you can get rid of the square roots by squaring, that's a good way to do it. Okay. So in other words, when you can simplify the equation before differentiating, then by all means do it, because after that it will be very easy to differentiate. So I square both sides. 3 squared is 9, and squaring the left side just got rid of the square root. Square root and square cancel. Now we differentiate. X squared differentiates to 2x. Y squared differentiates to 2y prime. 2 times 16 is 32. And then 9 is a constant, so if you differentiate, it's 0. We solve for y prime by moving the 2x to the other side and dividing by y prime, 32y. We solve for y prime by dividing by 32y. And you don't have to, but it's nice to reduce. And that's it. That's the answer. Find the equation of the tangent line at 1, 2 of this graph. Okay. This is an application of the implicit differentiation. When you have an equation like this, it's very hard to solve for y. So what you have is a curve which is defined implicitly. For every given value of x, if you solve this equation, you get some value of y. So you can get some graph by making a table of x and y values. And certainly on that graph, you can think about the tangent line at 1, 2. The problem is, because it's hard to solve this equation itself as a function of x, you can't write y as a function of x. And because of that, you have to differentiate this implicitly. So let's see how it's done. Now, before we do that, let's write down the point slope form. Y minus y1 equals to mx minus x1. And the reason you do this is because we see this thing called tangent line. Anytime you see the question tangent line, this is the first formula you want to write down. Where x1, y1 is one of the points on the line, and since it has to pass through 1, 2, I can use x1 as 1 and y1 as 2, which leads me to write down y minus 2 is equal to mx minus 1. So we have almost the solution. The answer is this. Well, not quite yet, because we don't know the value of m. So right now, the only question is, what is the value of m? And we know that the value of m is given by y prime. We need to know the value of y prime when x is 1 and y is 2. That's why we want to use the implicit differentiation. So let's go ahead and use implicit differentiation. X squared differentiates to 2x. This we need the product rule. 3 comes down, we need to use the chain rule, and 1 prime is 0. Okay, 4x prime is just 4. And I have 4x y prime minus 3y squared y prime equal to 0. And I see that these two have y primes, whereas these other ones don't have y primes. So let's move these two to the other side. 2x plus 4y stays, whereas 4xy prime became negative 4xy prime, and negative 3y squared y prime became plus 3y squared y prime. When we factor the y prime out, we end up with 3y squared, and then when we take away y prime from here, we get minus 4x. That is 2x plus 4y, and then we divide both sides by this, which gives us y prime equals to 2x plus 4y divided by 3y squared minus 4x. Okay, this is almost the slope, not quite yet, because we need the slope when x is 1 and y is 2. So let's go ahead and figure that out. Y prime when x is 1 and y is 2 is 2 times 1 plus 4 times 2, 3 times 2 squared minus 4 times 1. That's 8 plus 2, that's 10 on the top. And then that's 12. 12 minus 4 is 8, which gives us 5 over 4 as the slope. That's our value of m. Now plug it back into our point slope form. That gives us the final answer, which is y minus 2 equals to 5 over 4 x minus 1. Find 2 points on the graph of this which intersects the vertical line x equals to negative 1, and each point evaluate y prime. Okay, if x is negative 1, what do we get? Negative 1 cubed minus 2 times negative 1y plus 3y squared equal to 0. And I like to use y squared first. I want to write down y squared first. It's 3y squared plus 2y minus 1 equal to 0. Negative 1 cubed is odd number of powers for negative 1, so it's still negative 1. Negative times negative is positive. Okay, now you can either factor this, which is not too bad. You can easily factor this, but if you don't know how to factor when you have a number here that's not 1, in that case the next best thing would be to use the quadratic formula, which says negative b plus minus square root of b squared minus 4ac all over 2a. And in our case, b is 2, 2 squared is 4, 4 times a is 3, whereas c is negative 1, all over twice of 3. A is 3. Okay, so it's negative 2 plus minus square root of, that's 12. 12 times negative is positive, so 12 plus 4, that's 16 over 6. And I do know the value of 16, square root of 16, that's 4. And that means it's either negative 2 minus 4 over 6, which gives you negative 1, or negative 2 plus 4 over 6, which is 2 over 6, which is 1/3. So these are the two solutions for y. Okay, so since x is equal to negative 1, we know the 2 points. Points are, you have negative 1 comma negative 1 and negative 1 comma 1/3. Now at each point we need to find out y prime. That should be obtained by using the implicit differentiation. Now this is a quadratic equation for y, so it is possible to solve this for y, but that's still really hard to differentiate. It's much better to differentiate this using implicit differentiation. So let's go ahead and differentiate. Differentiate. x cubed differentiates as 3x squared, 2x, and then 2x y prime. By the way, this was a single thing which had the minus, so really these two should both have the minus. Or you should think of this to have a parenthesis, okay? Since these two all come from a single thing, they should be in parentheses. And then when you differentiate y squared, 2 comes down, that's 6y, but then you differentiate the inside function and attach, so 6y y prime equal to 0. So what you get is 3x squared, sorry, there should have been a derivative here, 3x squared minus 2y minus 2xy prime plus 6y y prime equal to 0. Move these two to the other side and you get 3x squared minus 2y equals to 2xy prime minus 6y y prime. Okay, when you factor the y prime out, I end up with 2x minus 6y. On the left side is 3x squared minus 2y. Okay, divide by 2x minus 6y and you have the derivative. 3x squared minus 2y over 2x minus 6y. Well, what are we looking for? We're looking for this y prime at -1, -1, right? Let me see. I need more room, so let me erase a little bit. Erase this part. Okay, so we need to evaluate y prime at -1, -1, which is -1 squared minus 2 -1, 2 times -1 minus 6 -1, and that is 3 plus 2, so you get 5 on top, positive 6 minus 2, that's 4 on the bottom. So you get 5 over 4 from y prime of -1, -1. And then for y prime at -1 and 1/3, this is 3 times -1 squared minus 2 times 1/3 over 2 times -1 minus 6 times 1/3. This is 3 minus 2/3. And then 6 divided by 3 is 2. And that's also -2. So -2 minus 2 is -4 down here. You can certainly put this into a single fraction and do keep, change, flip, or whatever. I would just simply multiply by 3 top and bottom to get an answer. Okay, so 3 times 3 is 9. 3 times 2/3, well, 3 will cancel, leaving you with 2. -4 times 3 is -12, so this is -7 over 12. And the answers are 5 over 4 and -7 over 12. A street light is mounted at the top of a 15 feet tall pole. A man 6 feet tall walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of the shadow moving when he is 40 feet from the pole? Okay, so you have this 15 feet lamp, and there's a guy here who is 6 feet tall, 6 feet, and then there's a shadow because of the light, and this guy is walking away from the pole with a speed of 5 feet per second. Okay. Then how fast is the tip of the shadow moving when he is 40 feet from the pole? Okay. Now, the simplified picture of this would be 15 here, and the guy is 6. These two lengths never change as this person walks away from the pole. So you should definitely write these numbers down in the simplified picture. And then we somehow have to express 5 feet per second. That's speed. Speed is a rate of change of some variable. So we have to express 5 feet per second as the derivative of something. So what changes as he moves away from the pole? Well, the distance from the person to the lamppost changes, right? It becomes greater and greater, and it increases at the rate of 5 feet per second because that's how fast he's moving. So we should assign a variable x so that we can say dx dt is equal to 5. Also, when he's moving, the length of the shadow changes. Actually, if he goes further away, the shadow will increase because he's further away, the angles change. And the length of the shadow is tracked by this y. Okay. However, when it's being asked how fast is the tip of the shadow moving when he is 40 feet from the pole, it's actually the distance from the pole that is changing. See, when you want to measure the rate of change, when you want to measure the speed of some object, speed has to be measured with respect to some fixed object. Certainly y does increase, and it seems to be related with the speed at which the tip of shadow is increasing, but y is not a good variable to keep track of the speed of the tip of the shadow because it's in relation to the man's place, which is also changing as he's moving. So y is not the one to use. Rather, what you want to use is assign a variable to some fixed object. The only fixed object in this picture is the lamppost, so you have to make that a z and write down the question in the following way. How fast is z changing when the man is 40 feet away from the pole? So when x is 40. So this is basically the question. And if you think about it, everything that you've seen in this word problem is now translated into derivatives, expressions, and this geometric shape. So now you don't have to worry about reading this anymore. We will just work with this thing. Okay. As any related rates question works, you see rate of change of x and rate of change of z, so you need a relationship between x and z in order to figure out the relationship between the derivative of x and derivative of z. So what is the relationship between x and z? Well, it goes like this. You have a small triangle and a big triangle. And when you have two triangles, often you want to use the similar triangles. You want to use the ratio. So in this small triangle, what 6 is to y, in the big triangle, what 15 is to z. Okay. Now this is not so good because now I have a relationship between y and z. So maybe I have to replace y by something that uses x or z. Well, if you look at this picture again, we see that x plus y is z. So instead of y, I can solve this equation for y and say y is z minus x, and then I replace y by z minus x, and suddenly I have a relationship between x and z. We are always told to solve ratios by doing cross multiplication, so let's cross multiply. So z multiplies to 6, which gives you 6z. Z minus x multiplied by 15, so you get 15z minus 15x. Okay, we can further simplify. It's a good idea to simplify before you differentiate. That makes the question easier to solve. Let me move the 15x on this side so that it's positive, and also 6x to the other side so it's negative. So we have 15x, 15z minus 6z, so that 15x is equal to 9z. And that's the relationship. What I can do now is to differentiate this, and that's going to give me the relationship between the derivatives. So let's differentiate. If I differentiate x, that's dx dt. And when I say differentiate, I really mean I'm trying to differentiate by t. I'm trying to do d dt. So if I take this and differentiate by d dt, x changes with respect to time, z changes with respect to time, so they're both functions of t. So when you differentiate x, you get dx dt. When you differentiate z, you get dz dt. Alright, now we have, I have dx dt, which is 5, so I'm going to put that in there. 15 times 5 equals to 9 dz dt. 15 times 5 is 75, and you divide by 9 to get what dz dt is. And if I factor top and bottom by 3, I get 25 over 3 as dz dt, and therefore the answer is, this is 8 1/3, which is 8.333, and the units are feet per second. So that is the answer. Two cars start moving at the same point. One travels south at 60 miles per hour and the other travels west at 25 miles per hour. At what rate is the distance between cars increasing 2 hours later? Okay. We have one car traveling south 60 miles per hour and another car west at 25 miles per hour. At what rate is the distance between the cars increasing 2 hours later? Okay, so I think what we're looking at is the following thing. I have the first car, let's assign the variable x for the first car. Second car has y. And the distance between the two, let's put a z there. And it's forming a right triangle. 60 miles per hour is the rate of change of x, so we should write this dx dt equals to 60, and then 25 miles per hour is dy dt. At what rate is the distance between cars increasing 2 hours later? So it's asking for rate of change of the distance of the cars when time t is equal to 2 hours. Well, let's come up with a relationship between x, y, and z, and we'll think about what to do with t equals to 2 hours later. Now, you have a single right triangle. In that case, the most popular one that's being used is the Pythagorean Theorem. So we write down the Pythagorean Theorem. Squares of the square sum of the two legs is equal to the square of the hypotenuse. That's the Pythagorean Theorem, right? We take this and we differentiate everything. All of these are functions of t, so you have to use the chain rule when you differentiate. So 2x, and then the derivative of the inside function, 2y, and the derivative of the inside function, 2z, and the derivative of the inside function. And then we have 2x, x prime is the rate of change of x, so it's 60. 2y, y prime is the rate of change of y, which is 25. And then 2z, and then z prime. Well, z prime is exactly what we want to know. We want to know dz dt. Now we still have x, y, and z, which should be a fixed value when t is 2 hours. So let's think about this. After 2 hours, how far did the first car travel? Well, it's moving at 60 miles per hour, so x must be 60 miles per hour and went for 2 hours, which is 120 miles. Whereas y would be, it's going at 25 miles times 2 hours is going to be 50 hours. And then z, using this formula here, z is the square root of x squared plus y squared. That gives you 120 squared plus 50 squared. And if you calculate this, you're going to find it's 130. The reason I know this is because the ratio is 5 to 12 to 13. It's a Pythagorean triple. But you can figure this out just by using a calculator. Okay, so I have the values. Just plug them in. So I have, well, let's divide everything by 2 just to simplify. I have the value, so x is 120 times 60, 50 times 25, and then 130 times z prime. And if you solve this for z prime, the answer is going to be something like 845 over 13, which ends up being 65 miles per hour. Okay, number 10. At noon, ship A is 100 kilometers west of ship B. Ship A is sailing south at 35 kilometers. Ship B is sailing north at 25 kilometers. How fast is the distance between the ships changing at 4 p.m.? So we have ship A and ship B. Distance between them is 100. And then it goes up. Actually, ship A goes down. And then ship B goes up. It's going north. And then the speed going south is 35 miles per hour and not kilometers per hour. And then ship B is going north at 25 kilometers per hour. Okay, the simplified picture would be something like the following. You have 100 here going up, going down, and these are both changing, so you should put variables here. So I put x here and y here. Now, how fast is the distance between the two ships changing at 4 p.m.? So we're looking at the distance between the two ships. And let's assign this as z. And we have now two triangles. Actually, we even know that these two triangles are similar, but that's similar triangles is not the one that you want to use here, because this z is like the hypotenuse, and in that case you usually want to use the Pythagorean theorem. So in order to use the Pythagorean theorem, we're going to do this. I'm going to add to this picture these extra lines, make it a rectangle, so that if this is 100, this side will be 100. If this is x, this side will be x. And what you end up with is y, and then x, and 100, and z. And that means the Pythagorean theorem reads 100 squared plus x plus y squared equal to z squared, which can be now used to find the relationship between the derivatives. Okay, 25 kilometers per h is the rate of change of y. We assign the variable y for it, so dy dt is 25, and dx dt is 35. And then we differentiate this. Differentiating this gives you derivative of 100 squared. Because this is a constant, it will give you 0 when you differentiate. This one you will need to use the chain rule, 2 times x plus y, and the derivative of x plus y should be put here because x plus y is the inside function. Again, the chain rule, 2 times z, and the derivative of the inside function should be attached. So you end up with 2 times x plus y and x prime plus y prime, 2zz prime. Oh, I should have written down the questions also. What is it asking? It's asking for dz dt when t is 4 hours after they departed, right? It started at 12 noon, and now it's 4 p.m., so the time spent is 4 hours. So that's what we are looking for. So we are looking for this z prime. Now x prime is given as 35, y prime is given as 25, so you need to do 35 plus 25, which is just 60. 2 and 2 can cancel. And I still need to know what x and y and z are in order to find out z prime. Z prime is what we want. Now at t equals to 4, at 4 hours, y is, let's see, x is 4 times 35. Time times speed gives you the distance traveled, which is 140. And y is 4 times 25, which is 100. And because I have 100 squared plus x plus y is 240 squared equal to z squared, I can also figure out the value of z, which is 260. If you take the square root of this, you're going to see that it's 260. And therefore, plugging in everything here, you get z prime equals to 60 times x plus y, which is 240, divided by z, which is 260. And if you reduce this, you get 720 over 13 kilometers per hour. Number 11. A boat is pulled into the dock by a rope attached to the bow of the boat and passing through a pulley on the dock that is 1 meter higher than the bow of the boat. If the rope is pulled at a rate of 1 meters per second, how fast is the boat approaching the dock when it's 8 meters from the dock? Okay, so here's the picture. Here's the dock, and here's the water, and there's a boat, and there's a bow, and there's a so here's the bow. There's a pulley which is up here, and there's a rope tied to here. And this height difference is 1 meters. And this rope is being pulled at 1 meters per second, so this is actually changing. Length of this is changing at the speed of 1 meters per second. Now what we're really seeing is this right triangle, because the question is asking for how fast is the boat approaching the dock, which means we need to know the speed at which the boat is moving, so we need to know the change of this distance. This height is 1 meter, it's fixed, and this rate of change is given as 1 meters per second. So the simplified picture in this case would be a right triangle that looks like this, where 1 is the height of the right triangle. Let's call this as x, which is changing, and let's call this as y or z. I'll just put z because I've been using z for the hypothesis, but you don't have to. You can use y. Okay. All right. Now we have this right triangle, and dz dt is 1 meters per second, and since z is being decreased, let's write down dz dt as -1. And the question is being asked like this: what is dx dt when x is equal to 8? Yeah, when x is 8. So that's the question. Now, whenever you solve these related rates questions, it's important to circle these words when or after or at. These are markers where it says the numbers that come after this word should be used only after differentiation. In the symbols I write, the notation I write, I use this when as a vertical bar and then write down the number here. That way I know I should be first computing the derivative and then plugging in this number. that happens to be a major source of confusion. See, a lot of the mistakes happen because when students write down the question, when they draw, they put 8 here. But that's no good, because if you put 8 here, then it means that this length does not change. But this is changing because the boat is approaching, and therefore this is shrinking. So you have to put a variable. So remember always to put variables to the sides where it changes. Okay, now we have a single triangle. Therefore, what do we use? We use the Pythagorean Theorem, which says square of the two legs is the square of the hypotenuse. And that gives us x squared plus 1 equal to z squared. And then we differentiate this, which is 2x x prime. Derivative of 1 is 0. 2z z prime. I do know that z prime is negative 1, so let's put that in there. So negative 1 here is negative 2z. And we're looking for, now that we have differentiated, now we can use this 8. So put that 8 in there, and then x prime is the one that we want to find out. Okay. So when we solve for x prime is negative 2z over 2 times 8. 2 reduces, so you have negative z over 8. We still need to figure out what this z is. And because x is given as 8, we might as well use this same equation to figure out what z is when x is 8. So put 8 into x. 8 squared is 64. So z would be square root of 65. Put that in here, and that's our answer. X prime is negative square root of 65 over 8. And because it's measured in meters per second, the answer is meters per second. Okay. Now suppose we have this relationship between x and y. What is the rate of change of y when x is negative 1 and all this? This question set 12 is basically about related rates, except that it's not a word problem. You're given a relationship between x and y, and you just have to solve for, you just have to differentiate this and solve for dy dt. So let's do that. We differentiate x squared y, and y cubed, and then 10. Because this is a product, we need to use the product rule, x squared prime y, x squared y prime. Y cubed is 3y squared times y prime. We have to use the chain rule, and 10 prime is 0. X squared prime is 2x, x squared y prime, plus 3y squared y prime equals to 0. And we're looking for dy dt when these are given. Now, note that you see this when, so these values should only be used after you differentiate. So I differentiate this, and now since I have the derivative, now I can plug in these numbers. Let's plug them in. X is negative 1, y is 2, x is negative 1, y prime is the one that we want to find out. Y prime is same as dy dt, that's the unknown. And then oh, sorry, I made a big mistake here. This is not implicit differentiation. We're differentiating by t, right? So when you differentiate x squared, not only you have 2x, but you should also have x prime there. Okay, so that's another thing that I forgot. So there's x prime here, and x prime is equal to 2, so there should be another 2 in here. Okay, and then y squared, that's 2 squared, y prime equal to 0. 2 times 2 times 2 is 8, so you have negative 8. Negative 1 squared is 1, so it's just y prime. And then this is 3 times 4, which is 12. 12y prime equal to 0. That gives us that y prime, 13y prime. If you move the negative 8 to the other side, I get 8. Therefore, the answer is y prime equals to 8 over 13. Question B is very similar. We have y squared equals to 1 plus 2x, differentiate both sides, 2y, y prime. Remember, we're differentiating by t, so when you differentiate x, you also need x prime. Okay, now we plug in dx dt as -3, and then x is 4, but we can't use that, and we have to find y prime. I have this y, so if I divide both sides by 2 and divide by y, I have y prime as -3 over y, but it's not a number, so how do we resolve this y? Well, the hint is right here. X is 4, so when x is 4, y should have a value, so let's see. Y squared is equal to 1 plus 2 times 4, which is 9. So y squared is 9, which means y is plus or minus 3. So when you plug that in, now we have y prime equal to -3 over plus or minus 3. So you actually have two cases, either -3 over +3, which will give you -1, or you can have -3 over -3, which will give you 1. So the answer will be y prime is 1, y prime is 1 or -1. That's the answer. This concludes the review. Thank you.